What's up, everybody? We got a late night Friday stream, and today we're going to be taking a look at the E3D Revo CR. Now, E3D did reach out to us to take a look at this, and ironically, this is actually one of the products we've been having on our radar, and we've also been testing the Revo system on a couple other machines over on Taurus side of things, so I'm really looking forward to put this on here. They sent this to us, and this is the 24-volt version, you can see here, and they even sent us the 4-nozzle kit. So this comes with a bunch of different nozzles. This is the first time I've actually looked at them. So I'm going to be looking at this with fresh eyes. So I haven't like gone through this before the stream. I do know that there are different nozzle sizes based on little rings. So we're going to look that up and see. I'm going to do the 0.4 on here, which is what we're used to using. And we'll go over the kit here. So let's go ahead and look at their product page and see what we've got going on here. So let's see. I did link their product page in the description, by the way. If you guys want to check that out. We do not carry this yet, but again, we want to go ahead and test things and make sure they all work well. So I want to put my stamp of approval on it if we can. So let's go ahead and take a look at their page here. And this should switch over to my monitor. Can we do that? Yay! There we go. So we got the REVO CR page. And let's see. So this is I believe this is the fully loaded kit. So these are like about 109 pounds. I think that's about the same in US dollars. I think the exchange rate's about the same, to be completely honest. I know there's a way to change the, like the amount of money, the type of denomination of funds you're looking at here. I think I'm missing it. They had it before where you can change between pounds and US dollars and whatnot. So let's see here. So the color coding, that's what I want to find out what the color coding is. So, all right. This is actually kind of nice. So they show you the breakdown of the actual hotend here. So you got your integrated Bowden clip here. So you got the actual retaining collet here, and then the clip, the heatsink, the spring that puts the pressure down between the heatsink and the heater block. It does come with a silicone sock, which is nice. I'm a big fan of those. And then you've got your nozzle. So I'm trying to find here. So here we go. REVO CR documentation. Let's see what they have. So we have their assembly guide, and here we go. Heater core identification. This is for the heater core, not nozzles. Where's the nozzles here? You got the assembly guide. I mean, this is pretty self-explanatory for me anyways. But this actually is good that they have information here. So the goal of these is that they actually are easy to assemble and easy to swap the nozzle, because the heat break and the nozzle are actually one piece. So I'm really curious to see how these perform, because that's going to eliminate any potential issues of having a leak between the heat break and the nozzle. So they don't have the Ender 2 Pro listed on here, but the Ender 2 Pro does have the same style hotend as the 3 Pro, V2, etc. So it's the same one. So meaning if it'll fit the Ender 3 and the CR10 and whatnot, they take the same hotend. We should be able to put this in. So we're going to find out. We're going to see if this actually works. I just assumed it would. Worst case scenario, I do have an Ender 3, but I don't see why this wouldn't work in here. I'm trying to find out. Here we go, nozzles. Let's see. Data sheets? Data sheets. All right, here. So they have the colors here. So what do we have in our kit here? We've got yellow, which is a 0.25. I actually do want to play with that. 0.4 is the red, so that's what we're going to use for the stream. Blue is the 0.6, which is what's currently in here. And then 0.8 is the green. So it looks like we have everything but the 0.15, which I'm perfectly fine with. We do have some of their Obsidian nozzles. I got to figure out where they went, because they accidentally shipped us some. So I want to check those out. I believe the Obsidian nozzles are their... I believe those are like their hardened ones, if I'm correct, for like abrasive materials. Let me see here. Yeah, so it's their wear-resistant one. So that's their wear-resistant nozzle. So you do, or will have, I don't know if they're available for purchase yet, options for a resistant nozzle, because brass nozzles are great for general printing, but the problem with brass nozzles is they're very soft. So if you run materials like glow in the dark through them, carbon fiber, anything with fill in them, especially like specifically metal fill, like wood fill is not usually abrasive, but anything that's got that extra additives in there usually will wear out and just ream out a brass nozzle. So brass nozzles are good for general purpose, but it's nice to have the options to have hardened ones. So we carry something similar called our Easy Flow nozzles, and those are a copper nozzle with a hardened plating on them, so you get good thermal transfer and wear resistance. So it's the same thing E3D does. They just call their obsidian nozzles. So yeah, Tor says it looks like October, so next month is when they're going to release them. So I already have the Ender 2 Pro kind of partially taken apart here. This is Krista's printer, so I figured I'll give her a little treat and she can have the fancy nozzle, especially since this is easy to work on and change. So if she wants to change nozzles, and we're going to do this right now. So remember the green, they said the green was a 0.4, so we're going to swap this out. And all you do on these is literally just unscrew it, and the threads feel buttery smooth. Like, the machining quality on this is great. You take it out, okay, and you've got this spring here that holds it. So look at it, actually holds it there, and then you just slide this up through and screw it in. Again, these threads feel fantastic. It looks like you can move this. Yeah, so this is nice, so you can adjust where your wires are going to come out. Typically, I think on the 2 Pro, I think they come out on the left-hand side. We'll find out when we take this apart. But the nice thing is they did think of this and have this able to be adjusted so you can put the wires wherever you want them, because they do have to exit a certain way on different machines. So, but this is how easy it is to change your nozzle out. There's no hot tightening because this is all one piece. So on your traditional hot ends and most hot ends, there's nothing wrong with this. It's just this is an easier design. Is your heat break is part of the nozzle here. Now the downside is when you need to change your nozzle out, you have to throw this whole thing out and get a new one. So the cost on these are more expensive than your standard nozzles, but you're trading off that ease of use. So if you're somebody that swaps nozzles a lot, this is actually a really nice. Really nice option here. So 0.4, wrong nozzle. I thought I looked up the green. Did I forget that already? Let me see. I thought it was green. Hang on. I'm pulling it back up. Oh, I did get that wrong. Red. Why did I think green? All right, well, I just mixed myself up another thing of maw. So hopefully that should start kicking in soon. I just started drinking that because it's towards the end of the day. I had a long day. I was working on our AC unit out in the shop. Finally got that going. So that was pretty satisfying. But look at it. Bam. All right. I do not want an alcoholic beverage right now, Krista. I appreciate the offer, but I'm already not on the ball. So someone said we take these off. Oh, look at that. Right underneath, if you take the little sock off, it tells you what the nozzle size is. That's awesome. So these are not only giving you an indicator of what size the nozzle is, but these also serve as, further protection thermally, and also preventing things from getting stuck on here. So green, I feel like green would be overkill on this. It'd be fun to play with. So I have played with 0.8 nozzles before. I have one on one of my other machines, but this little printer, while it could use it, it's kind of impractical because it's usually I use it for bigger prints. So, but the nice thing is with this system, we can change this out easily. So here's the first layer of the box. So you've got the nozzle set. So if you didn't get the fancy kit, you would just get the hot end with one nozzle. They did send us out the, the full-blown kit, which I appreciate. And this was something I noticed here. Look at, they actually gave us pre-crimped wire. So you can actually do this installation without any soldering. So this is nice to see. And look at, they must be wanting to get some brownie points. They have crimped ferrules on the end here. So this is for the heater, and the thermistor actually just uses a standard DuPont connection here, which will tack onto most boards, even if they have the 2-pin JST XHs. And they do give us a little piece of PTFE tubing for some reason. I'm not quite sure what the rationale for that is. Unless it just made it into our box. Like, I don't know. I don't know why there's a piece of PTFE in here. It's interesting. And I don't think so. The PTFE is going to line up right at the end here inside the hot end. And these are all metal hot ends, so you can go up to higher temps. I think they say it's 300C. They do give you quick connects here, which is nice. I'm assuming this is for if you want to do a solderless installation. We actually use these style connectors, and if you buy fans from us, we include these here. Now, I'm going to leave it up to you guys. Should I solder in their wiring or should I replace it? Because here's the thing. We could use these on this printer, but then we're going to have to go all the way back and undo this. And honestly, I don't feel like doing that. Typically, if I replace a hot end, I will pull the sheathing back. We will solder in the new wires. Okay. But this is also an option too if you guys don't solder. So it's good that they comes with it. Yeah. So anyways, let's get into it. So we're gonna go ahead and start taking apart our Ender 2. Now I already have the bottom off of this. And one thing I did to make working on my Ender 2 Pro here easier is I actually drilled out little holes in the feet that line up with the screws in the corners here. So I can just stick my hex key through. It's a 2mm hex key and go right into here without having to take this off. So I already have this off because this Ender 2 Pro actually has our Easy Board 2 in it. We actually have if you guys aren't aware of this, we do actually sell cables here that go directly from the 5-pin connectors that Creality uses to the standard 4-pin connectors that you'll find on most control boards. And you can see here, we do include a ground wire here because the 5th wire here is actually for a ground. And what I did, and you don't have to do this, I just did this because I have the tools and the connectors. You could either, if you get the wiring kit from us, you can actually just get rid of this wire, just yank it out of here. Or if you have an eye loop, you can actually do what I did, which is twist them all together. So here's all 4 of my stepper wire motor ground wires. Crimp it onto a little eye loop and then put it through the hole here so they're still grounded. Now, having extra grounding is not a bad thing. I do actually like this, but yeah. So this actually has an Easy Board, and you can see I already put crimp ferrules on here. I really don't want to replace all the wiring. I could. Is this going to even be long enough? Let's see. I think it is. So if we were to use their wire, yeah, we'd be able to get up to the hot end with this. But the thing is, like, these are, what is this, like 20 gauge? Yeah, these are 20 gauge. So this is the same gauge that it comes with. The problem is why I don't want to replace the wires. If you guys look at everything's zip tied from the front to the back. It's all cable managed. So we got our EasyABL sensor cable here. We've got our Easy Out filament sensor. So I'm going to splice these in because not many people show doing that, and I have the soldering equipment here. So the first thing I'm going to do is I'm going to take apart the hot end, and then we're going to cut my zip ties here that are holding everything together. And let me grab my handy-dandy TH3D toolkit. Yeah, but pulling the wires out through these sleeves is a pain. Now, I could, if I really wanted to save time, I could just not use their wires, disconnect them, and run them alongside like all these additional wires. So this is an EasyABL micro on here, and then you've got your PTFE tubing on here. So, yeah, I'm just going to solder. Otherwise, it's going to be way longer. But I wanted to point out that they did include the cables. Now, what I'm going to do is I'm going to cut their cables and splice these into the existing wires, and I will do the splices up in here. So, all right, so let's go ahead and undo my zip ties here. So most of your printers come with zip ties anyways. So go ahead and just snip these because we need to get into the cable harness here. So if I was replacing the wire instead of reusing the existing ones, I would have to do this all the way back to the printer, which is a pain. So what I like to do when I am replacing a hot end or thermistor or heater cartridge, I will pull back the sheathing here. So we got this nice sheathing here, and I'm just going to tape it to keep it out of the way while I'm working on the machine. So I'm going to go back here, okay? And I'm just going to take this and put a little piece of electrical tape over it. And we're going to take this off when we're done, and this will keep it from riding back up. And you can see here, we've got our two, where are they here? We've got our two heater lines here, and they're actually labeled. This is interesting. There's actually a label inside the wire here. And to be honest, this is actually nicer wire than what they come with. This is just some basic wire. I'm not going to complain about people giving stuff for free with the products, but this is actually a nicer wire. This is that silicone wire with the outer, like a cloth coating over it. So on your printer, typically, you'll have the heater lines will be like red, or they might be a black and white checkered, or even blue, depending on what heater cartridge they use. And then your thermistor lines typically are the white ones. So when we take the hot end off here, you'll see what I mean, because those will go to the heater cartridge and the, what's the word I'm looking for? The heater cartridge and the thermistor that are already in here. So we're going to use their thermistor and their heater cartridge. So on the Ender 2 Pro, there's this one screw on the back. And we take that out. Got my handy dandy magnetic tray here. We're going to put that in. And then this cover should come off if memory serves correct. It's been a while since I've worked on this. This printer's actually been very, very reliable. And like Krista's been using it with no issues. So I think the only thing I've done on this in terms of this area is we did put one of our fans in here. These are the 24 volt 40 millimeter fans, because the stock fan was god-awful loud. So that's why you can see here, I spliced in here. Look at that. We're going to do the same thing. We're going to do a nice heat shrunk splice here, and it's going to look all professional. So on this printer head, go ahead and move this up so we have some working area. On this printer head here, they actually have a ground wire going to it. So we're going to retain that when we put this all back together. So I'm going to take the stock screws out of the hot end here. And we're also going to need to pull the filament out. So there is filament in this. I should be able to just like unclip this Bowden tube here and back it out. And we're going to reuse the PTFE tube that came with this. So I'm going to go ahead and back this out. So this is one of our fittings on here. I've swapped this out because Creality, if you guys have owned a Creality printer, you'll know how terrible their fittings are. So I preemptively replace them on any new builds just because I don't want to deal with issues down the road. The fittings are cheap. So why not? But I will put this hot end in my parts drawer. Let's see. I should be able to just loosen up my extruder. And is it going to pull out? Nope, we're going to have to heat it up. So this hot end is a PTFE line hot end. So this goes down into the melt zone. So the reason this isn't pulling out is it's in the melt zone. Sometimes you can get them to pull out without having any issues. But in this case, we're going to need to turn this on and actually let it heat up. So I'm going to go ahead and do that now because there is filament in here. All right. We're going to let this heat up so we can get the PTFE tube out. So I'll pull the filament out. My head's blocking it, but my filament's over here on the left. And then we're going to go ahead and pull the Bowden tube out. All right. Well, since we got to wait for that to go, how's everybody doing on this Friday evening or Saturday if you're living in the future in another time zone? Tim's going to burn a finger. Wow. Wow. I see. You have little faith. Here. Let's make it so I'm less likely to burn a finger, and we'll put the hot end back on there. How's that? Probably be easier anyways that way. Yeah, if you guys can't tell, none of our videos, none of our streams are scripted. This is all just, we jump in and we do it. So, where's my maw? I have my maw and my thermo flask with my LTT store stickers. Wow. Look at that. There's also Murph stickers and everything. I did the whole sticker thing. I'm cool. Give me 1 second. My neighbor is texting me. We got like a couple more degrees ago till I can pull the filament anyways. Hang on. My neighbor is texting me. I'm letting my neighbor, I ran an Ethernet cable literally across my driveway to get my neighbor internet because Comcast is not turning their service on yet. And the driveway is getting seal coated tomorrow. So, trying to be a good neighbor here. Here, have some interwebs. I have unlimited data anyway. So, all right. Well, we're at 196, so I should be able to unload the filament now. Yes, I can. Looks like Krista had some purple stuff in here. Oh, I think this is that silky purple I picked up for that Tor. Tor just had to show her, like, look at, it's silky purple. I can't even remember the brand, so don't ask. But that's what was in there. So I went ahead and pulled the filament out, and now we're going to pull the PTFE tube out. And the end of this will be hot because this is in the melt zone. So you can see here, this is actually in the melt zone. I'm going to go ahead and clip this end off. And one of the things is your PTFE fitting will most of the time not want to come out. I usually just take the wrench here and try to slide it down like that. And it just ran across the floor. We will get that right now. It's right here. All right. So I'm going to go ahead and just turn the printer off now. And we can start working on this. So the hot end is hot right now. I'm going to go ahead and snip the end off of the PTFE. So you can see here, this PTFE was in the melt zone here. And we're going to go ahead and snip this off because we can reuse this tube for the new hot end. Now, if you're replacing the stock tubing at the same time, so this is our tough tube. So if you guys want something that's a little bit tighter in terms of accuracy, like this, the hole on here is 1.9 millimeters internal diameter. You want something that's a little more accurate, now would be a good time to replace it. But I already have our tough tube on here, so we're going to go ahead and just leave that. Trying to think of the order of operation here. All right, so we're going to go ahead and snip the lines here. So I'm going to snip the heater lines. Now, neither the heater lines nor our thermistor lines are polarity sensitive, so there's no worrying about positive or negative on here. So I usually like to snip them so they're kind of staggered, so the splices are not right up on each other. And I'm going to do that with the thermistor line as well. So we're going to come back a little bit here. Just like that. And now we'll be able to take the hot end off. So you can see here, I got my hot end wires just sitting there, and we're going to splice in with a soldering iron. Although I guess E3D is a British company, so should I say solder for this stream? Isn't that what you guys like calling it? Solder? Not solder, solder. I don't know. So there we go. There's our old hot end, and I'm going to put this in my parts drawer because this is still a perfectly good hot end for spare parts. So we're going to go ahead and set that over there and forget it exists for now. All right. So now we need to figure out our wire length. So installing this is literally as simple as taking the old one off, putting it in, and then making your connections. So I'm going to go ahead and just do the same thing. I'm going to put this through the face here. And if you notice, there's a flat side, okay? This is going to go towards your X carriage, okay? So when you're putting this on, you want to make sure that you get the right side because it will not fit the other way. So you can tell they kind of like copied the Creality size of this, but they did increase the size of the fins. So you can see it's rounded on the front here. And we're just going to mount this up. It literally bolts right up. So if you guys are looking for something that's pretty quick that doesn't need like a printed mount or something like our multi-mount to mount up to your printer, this is a good option because it's just as simple as switching this out. And then you get the Revo. And if we look here, the profile on this is actually the same as stock. So the nozzle sits down a little bit lower. So that's good. They did do their homework in terms of making this the correct size. Now, the wires on the stock hot end exited out this way, so I'm actually going to take this off because I can't spin this quite all the way around. Oh, wait, hang on. No, I can't do it because even with this out, we want the wires coming up this way, which is where they were on the stock hot end. And the reason you do that is on some printers, too, especially where your cables exit, you don't want to have it taking a different path. if that makes sense, because there's different things that will get in the way. So I'm going to go ahead and it looks like it's clockwise, or is that clockwise? No, counterclockwise, to get the cables to rotate, because the spring like binds up if you're not doing it counterclockwise. Now I'm going to go ahead and bend this up, and then we're going to go ahead and put this in. And put the screw back in. And I'm really curious to see how the print quality is on this. Can we go up a little bit further? Yes, we can. Their termination here is really tight. There's almost like a pack of components, or it's probably splices on the right side here where this exits. So let's give you a better... There we go. All right, so we got our ground cable here. We got the cables exiting on the right side, which is where the stock one is. I don't know which printers exit on the left or the right. I've worked on so many Creality printers, it's just a blur. But that's all it takes to mount this up. The hardest part now is just going to be doing the splices. So here's the thing. I actually do not like having quick connects on here. Because this is a lot of extra bulk here. And I can hide these in the wire harness. I can hide these in the wire harness, but then we're going to have a bulge in there, which is fine. We're going to do that, but typically I don't use these. Like, I will, even sometimes, like on some of the E3D installs I've done on my machines, I'll cut these and splice these directly into the stock wires. And like this, we're going to get rid of this, because this is just going to get in the way. And there is a serial number on here. So if this was one I purchased and I'd care about the warranty, I would probably hang on to this and like maybe tape it to the printer somewhere, because there is actually a serial number on here. And I'm assuming this is just for the heater core. All right. So we've got all the wires exiting. We can go ahead and put our fan shroud back on now. Oh, wait, I lied. We have to put the PTFE tube in. So I'm going to take the clip off. And we're going to go ahead and put our Bowden tube in there. And we're going to insert it until it stops. Which is not much, apparently. Unless I'm hanging up on the inside. Is it that short of a distance? I think it might be that short of a distance. It's like, I don't know, maybe 15 millimeters, if that. That's interesting. So, all right. I'm going to put the clip on. I just usually like give it another push to make sure it's in there. And yeah, that collet is actually holding on really well. So let's go ahead, and all we have to do after this is make the electrical connections. So we're going to splice those in and then redo our cable management and update the firmware, because I believe we have to change the thermistor. I will look at their documentation, but I believe we have to change the thermistor. So this clears just fine. Inside here, the fan is actually right in front of the heatsink, so that's good. All right, make sure the printer power is unplugged. I'm going to go ahead and screw the screw back here in the rear that we took out. And I did notice here, they actually staggered the plugs here. Do you notice that? That's nice. So when we put this back into the housing, or the sleeving, we're actually not going to be like right up on everything. So we are going to be right here. So I'm going to cut these cables back a little bit further, because we've got our heater lines here. And we have to splice theirs in. So here's their heater line. So I'm going to go ahead and connect that here. So the two black wires are their heater line. And I'm going to kind of follow the existing wires that are already on here so I can get an idea of the length I need. So I'm going to come back to like right here. And again, I like staggering my splices so they're not right on top of each other. And then we're going to cut these leads to match the length here. So I'm going to go right about here for this one. And then right about here for that one. All right, so we're going to strip these, solder them, and we're going to remember the heat shrink, okay? Going to remember the heat shrink. All right. I had a thing of heat shrink out already. It's right here. Huzzah, heat shrink. Tim's Doom bin of heat shrink. Gender 2 Pro is a cute one. No firmware changes for the CR. They use the same thermistor as a stock failure. That is interesting. That's good. So this said it was 20 gauge. All right, I'm going to go ahead and strip this. And I believe the stock wiring is actually 18 on these. We're going to find out here. Yep. There is a fly in my office. There's a snake in my boot. All right, there we go. Those are stripped. Can you guys see everything okay? Hey, Tor, if you're watching, can you pull up and find the documentation for their thermistor and whatnot? I'm gonna get my lucky trusty Hacko over here with some lead solder. Leaded solder. I always use leaded solder. I love leaded solder. It just flows so nicely. How many of you guys that solder here, solder? How many guys that solder here use leaded solder versus lead free? I'm curious. I prefer leaded solder. I just find that it just flows better. But I'm curious to see what the other nerds here watching like using. What do you guys prefer? Leaded or lead-free solder? All right. I'm putting the heat shrink on the wires. I almost forgot to put my flare fitting on my HVAC on my HVAC line set before I did the flare. That's even worse than forgetting to do the heat shrink before you solder, because I did not have much copper to work with, because my line sets actually go from copper to braided. So I only had so much copper to work with. Thanks, Mr. Cool. All right, so we got a nice mechanical bond there. I'm going to go ahead and clean off my tip, because nobody likes a dirty tip. Keep your tip clean, okay? And we'll go ahead and just touch that there, let it heat up for a sec, and then I'm going to come in and just add the solder. I'll just pull it in, and then we're going to repeat. So we got the one power line and the other one, and that is quite warm because it was just heated up. All right. I might actually update the firmware on this, because I just realized when Krista asked to tell people what the name of the printer is, which is Ligma Mini. When I replaced the control board, it lost its custom name. There we go. And just like that, we've got some nice soldered connections here, soldered connections. All right, I'm going to go ahead and pull my heat shrink up. And now one thing to note is that if you just got done soldering, your heat shrink might be hot enough to shrink your heat shrink. So just keep an eye on that. So let me grab my trusty little, I've had this thing for, I don't even know, this is like a craft heat gun, and this is great for heat shrink. They're like 30 bucks, and it's actually made in Taiwan, not China, which is probably why it's lasted a long time. But these are awesome. So I don't know if I picked this up on Amazon or if I got it at a local store, but everybody asked me about the tools. So this is the Chandler Tool brand, and it's the CTHG 150D. I literally just use this for heat shrinking. That's all I use this for. because it's about 700 or 320 watts, I want to say. And as you see, does a fine job at getting the heat shrink taken care of. And it's also not like those like 1500 watt ones that'll just like cook everything in its path. So yes, it is weaker than like another hot air gun, but I don't want anything crazy. So, all right. So now we got to do the thermistor lines, and then we're almost done here. So, I mean, you don't have to do this installation this way. I do this just because I didn't want to pull all these wires out of here. Now, if you wanted to use their wires, you could just cut them and disconnect them, but I don't like leaving dead wires in harnesses. It can get very confusing for whoever the next person is that works on them. So, but you know, it's your printer. Do what you wish. But we are going to use their connections here. The other reason why I don't like using quick connects, like that are on this, is because that's one more point of failure in your printer, if that makes sense. Like, that's why I'm not a fan of doing these type of connections typically, because as your printer's hot end's moving back and forth, there's a chance that these are going to make poor contact, and it could trigger, you know, a thermal runaway condition where you know, the printer stops printing, you lose a print, etc. So I'm not a big fan of them, but I am going to use them just because I'm not going to splice onto their actual hot end wires. Your mileage may vary. I've just had bad luck with having extra connectors on things, specifically on hot ends, because, you know, your hot ends moved around quite a bit. And remember, I did cut these staggered here, so I'm going to do the same thing and trim this down. And we're just going to do the same thing again. So we're going to splice them in. I'm going to get my heat shrink on here. I'm going to remember to put the heat shrink on before I solder it. Make sure it covers both, or slides on both wire thicknesses. Because there's times where I grab you know, you got two different thickness of wires, and you grab one, you think it's going to fit both of them, and then you get it soldered and realize it won't slide over the other one. So just double check that before you commit to it. There we go. This wire gauge is a little thin. I think this is like 22 or 24. Theirs will probably strip a little easier. Yeah, it's actually the same internal thickness. It's just the insulation's thicker on the E3D one. All right, and let's just repeat. And if you notice, I'm not just taking the two ends and shoving them together and soldering them. We're making sure we have a nice mechanical bond on the wires before we actually solder them. And you want to do that. Just gives it a better connection. And the solder is going to flow in and make these two permanently attached here. So again, you want to just kind of heat it up for a sec, let the wire get hot, and it just helps with the solder flowing in better. There we go. There's one. And there's a second one. If any of you guys are watching and you own a 3D printer, you don't own a soldering iron, go right now and buy a soldering iron. Like, go online, go to your hardware store, even a cheap little $30 or $40 soldering iron, or even hell, probably wouldn't risk it on a $20 one. But go and pick yourself up a soldering iron, because the soldering iron is probably one of the most important tools after having a multimeter that you can have for working on your printer. You can do so many repairs with a soldering iron. So if you guys don't have one, get one. There's tons of videos on learning how to solder on YouTube. So highly recommend you have a soldering iron if you own a 3D printer. And don't be intimidated by it. Soldering is not hard. It just takes practice, and you get kind of a feel for how the solder flows. And the key is, you know, using rosin core solder that has, you know, the flux in it, and heating things up. And if the solder isn't flowing very well, add more flux. I actually have separate things of flux. As you see here, the rosin core solder that I used works just fine for wires. You know, but if you're doing more intricate things, having flux on hand is really handy. All right. There we go. I just bought one for $7 at Harbor Freight. That's a good deal. But hopefully it's more reliable than their jack stands. I am no stranger to Harbor Freight. I have actually, their toolboxes are really nice. And the trick is when you go to Harbor Freight, look at where it says that the product is made. The stuff that says made in China is usually their low-end stuff. And the stuff that's made in Taiwan is usually their better quality stuff. So, you know, they have like, you know, good, better, best type of marketing for their products, if that makes sense. So here you go. I'm pulling the sleeving back over the wires. It looks like I had some extra sleeving bunched up after my zip ties over here, so I'm just pulling this up so I can get this back down, and just like that, everything's back together. And you can see there is that lump there from the quick connects, but that's fine. I'm going to go ahead and put zip ties back on here, and then we're ready to turn it on and make sure everything works. I'm trying to remember where I put my big old bag of black zip ties. I have one in here. The question is, where did I put it? That's disappointing. I tried to prepare for the stream, but apparently I forgot to make sure I had my zip ties handy. Oh, wait. I got my big thing of zip ties here. And I do have smaller ones in this assortment, so there we go. All right. So we're going to go ahead and just re-secure all the wires back to the PTFE tube. Now here, look at my PTFE tube is actually sticking up more than it was before. So I'm going to go ahead and just trim it because I want it to be the same length. So the PTFE does not go in as far on these as it does on the other what's the word I'm looking for? On the other hotend, because this is an all metal hotend. So I'm going to go ahead and just trim this tube. Probably going to take off like, I don't know, 10, 15 millimeters and see. And actually, I'm going to replace this fitting. This is just the basic fitting that comes with the metal extruders we sell. And they're fine, but I prefer our upgraded ones. So we include just a basic fitting in there. And I believe I have our other fittings here in my drawer. Yes, I do. Here we go. So here's the better fittings. And this is all stuff we carry in the shop, too, in terms of these other parts. So this is your standard fitting that comes with most aluminum-type extruders, including ours. And then we also sell an upgraded one that is a little bit beefier and bites on better. So I'm going to go ahead and put that on here. And these you just snug up. You don't want to over tighten them because this is a pass-through fitting, meaning this tube will pass all the way into the extruder. So if you crank it down too much, you do run the risk of shearing it off because there's not, once they ream it out for the 4mm tube, there's not much left. So, but in terms of holding power, these are fantastic. All right, so let's see how the tube is now not bunching up. It's actually about the same position it was when we had the stock hotend. So, all right, time to button her up. Go ahead and put my zip ties back on. I've got my Easy ABL cable on here. And especially if you have a Bowden system, following your PTFE tube for your wire management is something I do all the time. It's fantastic. And it's nice because your PTFE tube is nice and rigid enough to support the wires. I'm going to go ahead and put one at the bottom here. Just to keep the sheathing from spraying up. And I'm going to put one more here just to secure the Easy ABL wire to the hotend so we don't have it flopping about in the breeze. And that's it. We're going to go ahead and plug the printer in and turn it on. And I didn't look at chat, but did we determine if we need to update the firmware or not for this new thermistor? I saw one person said we're not going to. I will have to lower my retraction after this upgrade. Yes, typically with all metals, you're going to have a lower retraction. That even goes for if you do something like our or heat break, or our metal heat break conversion for these hot ends. So this is an expensive hot end set, but you're getting ease of use on it with that nice switch out for the nozzles. But if you don't mind, if you don't change your nozzle that often, or you don't mind the traditional nozzle setup, we do have bimetal heat breaks for these the stock hot end on this, that then turns it into an all metal. So I'm gonna go ahead and plug my fan in. Now my Easy Board has a separate fan that's just for the control board, so I'm gonna go ahead and plug it into my fan 2 header. I'm gonna pop this back on. If this doesn't require any firmware updates, meaning the thermistor they're using is the same as the stock one, then you actually don't even need to take this off. I only took this off because I was working on this printer beforehand. So I'm gonna go ahead and put this back together. Just put the screws back in. You know, but if you did use their wiring, then you would, and not splice in like I did, then you would need to take this bottom panel off on this particular printer. So, but this installation procedure applies to any of the Creality printers. It's the same kind of thing. So any of their supported machines are going to be the same process setting this up. So I'm only going to put a couple of these in because I'm going to be working on this printer again for doing some updates and stuff, but I just wanted to have that in there. So let's see what chat's saying. I gotta pull up. Where's my chat bot? It's got my chat log here. I'm looking to see. Torres says just a PID tune. So if you're running our firmware, which we do have firmware for the stock control board as well as support for the Easy Board, which is what's in here. So this has our control board in it. You'll want to run what's called a PID tune. Now, I believe the stock firmware does not support PID tuning. So upgrading the firmware on this board, on the stock board, is actually really easy. It's done over an SD card, and you'll get a lot more features. So when we do a PID tune, what that means is, and I'll typically turn my fan on. So I'm going to go to the menu screen here. I'm going to go to temperature, and I'm going to set my fan to 100%, my layer fan. Okay, and then we're going to go into the configuration menu and and do a PID tune. Now, the one thing I backed out to the menu is to see the temperature. So this is reading this, basically, if these are within 1 degree, which they are, this tells me this thermistor is probably the same, so which is what people in chat were saying. So now that we know that, I'm going to go to configuration, and I believe it is under advanced settings. And then temperature, yeah. And then PID auto tune. So you can see here, PID auto tune E1. I'm going to hit this, and I'm going to do the PID auto tune at 230 because this printer primarily prints PLA. If I was doing ABS, I'd do like 240, 250. If I was doing PETG, I'd also do 240, 250. But any PID tune is going to be better than none. So I'll go ahead, and apparently I took too long. There's a timeout. But yeah, so we're going to go ahead and do a PID tune, and what this will do is this is going to tune the PID values, which is how the printer regulates its temperature to get to the target temperature and hold it. And it will make it so it's more stable and smooth. So if your temperature graph, like if you have it plugged into Octoprint, is like this, try running a PID tune. And you can do this right from the LCD if you're running our firmware. A lot of the stock firmwares, most of them do not have this built in. So this is another feature I talk about when we're talking about especially the touchscreen LCDs that we make replacement kits for. You don't have access to any of this stuff versus having the 128/64 style screen. So there's a lot of good things you can do with our firmware and these style screens. So it is heating up quick. Do you guys see how fast that's heating up? Do you remember how long it took to get to 200 with the old one? I'm impressed. That's freaking awesome. And that's a 40-watt heater. You can see here, it's a 40-watt heater. So because it's so small, it heats up quick. So you can see here, we hit the target temperature, so now it's going to cycle. So Krista wants Ligma Mini back on her screen, because like I said, I changed the control board. So one of the upsides of getting printers from me and living with me is that you get printers. The downside is occasionally I take those printers and I have to do testing on them, which is why Krista has not had her printer. I think she's been kind of missing it, to be honest. But the last thing I'm going to be doing with this printer, and I'm thinking maybe we'll do this on a Hangout stream and I'll clip it out for a separate one, is we're going to be taking the circuit board out of this. Okay, this is a Meanwell 150 watt 24 volt, and seeing if we're able to take this out of its metal enclosure and put it into the stock metal enclosure that is the power supply here, so we can actually have a Meanwell power supply board in this printer versus this off-brand one. So all right, did that finish its cycle already? Because it's back to the ABL ready. Let's see. If it did, the value should be different. I believe this is 20.7, 3.98, 26.9. Let's do it one more time. It doesn't hurt to do multiple ones. And while we're doing that, I'm going to go ahead and get her new firmware built using our easy firmware site. I'm going to call this the Ligma Mini V2. And I do have the Ender 2, that's the Ender 2 Pro. Oops. Ender 2 Pro. And we have the Easy Out V2. And we have the OEM Micro. I don't think hers requires any special settings. Other than telling it that we have Ender 2 Pro Micro Easy ABL, which is this is actually one of the prototypes of the printer we did a lot of the testing on. The extruder is replaced, but this is our upgraded aluminum one, which is the same steps per millimeter as the stock one, so I don't need to change anything there. I'll just switch over here to the main screen. So it is doing the PID cycle. It's just going really quick. So far, heating up time on the Revo is really nice. So here we go. This is the V2. We put a V2 board. This is the second iteration of the printer. V1 had the stock board. So on this printer, we've got our Easy Out sensor. We have told it that it's an Ender 2 Pro, because it is. And then we've got the Pro Micro OEM mount, so I uncommented that. And then for the custom setting of the name, so it changes it, we're going to go ahead and also change this here, because we have a tiny little bed. So I'm going to set this because the micro can go really far in. So we're going to do 10, and we're going to also tell this we want super fast probing. And we're going to set the name. Which is custom name. It's under the miscellaneous stuff here, so custom printer name. And using this setting in our firmware, this is not just for the Easy Board, any of our firmwares we put out. You can set your custom printer name. That will show, like right now it shows TH3D Easy ABL ready, so now it'll say Ligma Mini V2. And that's it. So I'm going to go ahead and tell it I'm not a robot, and I'm going to submit this, and now my server is going to compile it, and we're going to come back to the printer here, and let's just see if those PID values stuck. Now, once I update the firmware, I believe I'm going to have to redo the PID values, but they're stored in EEPROM, so I just did a store settings, and we're going to go ahead and heat this here and see how stable our temperature is. So I'm going to go to 230 here. And the other thing I want to check, since I did change the hotend, is I'm going to check to see where my nozzle is in relation to the Easy ABL. Make sure, haha, you see. So here's the thing. Whenever you guys work on your printer, on the hotend specifically, and this is if you have any ABL sensor, you might have to readjust your sensor, because look at the E3D is slightly shorter. So this was set so it was 1 millimeter higher than the nozzle, and now the sensor's hitting the bed before the nozzle is. So I'm going to have to adjust this and raise this up a little bit so it's 1 millimeter higher than the nozzle. Where's my little wrench I had? Here we go. Ah! It's not the right size. I think that might actually be a different size than what these I use for the eccentric. I think it's like an 11, but we're just going to go ahead and just use some pliers here. We're going to loosen that up. All right. So I'm going to have my nozzle on the bed, and I want to get a 1 millimeter distance. So let's just see. This SD slot adapter should be, oh, it's a little too thick. Business cards. There we go. 2 business cards should be about 1 millimeter here. So basically, I'm going to put this under there. We're going to adjust the sensor so the nozzle is on the bed right now. And I'm going to go ahead and adjust this so this is sitting a little bit higher. So whenever you guys work on your hot end, you have an ABL sensor, or even your Z end stop, you might have to adjust your Z end stop. Does that make sense? This is pretty standard. Go ahead and tighten that back up in the mount. And we can see the sensor needs to go down a little bit. We do not have a ton of detection distance on here, so I must have messed up the knob because we have a gap between the cards now. Womp womp. And that should be good. Let's double check that. We'll make sure the sensor triggers before the nozzle touches. Yep, we're good. All right. Okay. Tighten that down. And let's go ahead. So the temperature here, if we look, it's dead nuts. So it is, that PID tune was a success. So I'm going to just double check here that everything is working correctly. I hear something in the belt here. What the hell is in the belt? All right, well, printer maintenance time apparently. There's something in here. I hear something happening inside the belt tensioner here. And then we'll run a test print. What do you guys want us to print? Pick something small that's like a 15-20 minute print. What do we want to print down here for the inaugural test? I believe it's just 2 screws that holds this on. Yep. Oh, look at that. Filament got stuck in the belt path. I do love these tensioners that Creality uses on here. I wish they use them on more machines. They are starting to put them on more machines, but these are, I love belt tensioners. I'm never going to complain about belt tensioners. Even if they're crappy looking belt tensioners, I'll take crappy looking belt tensioners over no belt tensioners. I love these things. These are fantastic. And then we're going to update the firmware so Krista can have her printer name back. I'm sure my download site is done compiling it by now. It only takes about 30 to 45 seconds. So, why are we not threading in? There we go. Couldn't find the hole. I was a little too far forward. Had to move it back a little bit. Hate when that happens. All right. Oh, one of my little pieces of PTFE fell in here. Come on. You don't belong in there. Oh, somebody saw Andrew R. PTFE under the bed. Okay. So I'm going to go ahead and let me get the firmware on here because otherwise I'm going to forget and then she's not going to have her her printer sitting. So I'm going to up here. Tor is being such a creeper. He knows my IP address and he popped in on the... He popped in here. Is like, you need to redo your PID after flashing. Yes, you do. I All right, we're going to go ahead and download this. I'm going to go ahead and put it on my USB drive here. I don't think there's anything on this drive. There is. There's actually a firmware.cur, so I must have used this to flash another board on August 30th. We're going to clear that out. I'm going to save my firmware.bin. And I'm going to take the SD card out. And we're going to go ahead and turn the printer off. Put my card in. I hate the slot on this printer. Luckily, we use it with Octoprint. So rarely do we have to deal with it. So let's go ahead and update the firmware. And one of the ways you can tell it's taking firmware is you notice how it's taking a little bit to power on. It'll pull the firmware in and then boom, you get the logo. So should have 2.49. Actually, I don't think I'll need to redo the PID tune on here. You can see here now it says Ligament V2, so it took the firmware. I'm going to go ahead and take the SD card out. And I do have a USB cable, so we're going to print over USB for the test right from my computer. And this printer gets used with Octoprint. So this USB cutout is so small. There we go. Let's see. I think, now normally I recommend you reset your EEPROM, but it did actually store the PID. So I'm going to go ahead and jot that down. Now, in our firmware, if you know your PID values, you can actually put it in at compile time. So maybe I'll do that. But let's see. Temperature. So our P is 21.4. Our I is 4.19 and our D is 27.4. So there we go. So I wrote those down, and like I said, after any firmware flash, go ahead and reset your EEPROM. So I'm going to go back here, go to configuration, reset EEPROM, and then I'm going to go put those values back in, because if we look, they're going to be reverted back to the firmware default. So remember, our P was 21.4. Our I was 4.19. And then our D was 27.4. You can see that's a big difference. But it's fairly easy to put all this back in with the little knob here. So I'm going to go back up. I'm going to go back to configuration. We're going to store these settings. So these will save it to the printer's EEPROM. Now, since I reset the EEPROM, I'm also going to have to reset my Z offset because I do have our EasyABL on here. And let's just double check that everything's working correctly. So our sensor's homing in the center. It's not crashing. We're good. So I'm going to go ahead and load up some filament here. I got a roll of coax navy blue. We're not going to use white filament because, dear God, white filament is so hard to show print quality on camera. It just, the way it reflects the light is just not a good representation of how it looks. You know, it tends to hide flaws and not really show anything other than it all merging in. So, all right, we're loading the filament in. I'm going to tell it to heat the nozzle. Let's just go ahead and preheat PLA. Man, that heat ups quick. There was a snap. Oh, this filament was used by another printer. There's teeth marks in here. Okay, hang on. That's why it snapped on me. All right. Let's try that again. This roll's also been sitting out for a little bit, but it'll print just fine. All right. Get in the hole. I think I need to give her one of those new fancy Tough Extruder V2s. What do you guys think? Maybe I'll also use this printer for the demo for how to assemble and use that extruder. Because that's another video I gotta do. All right. Okay, we're into the hot end. I can feel it. Are we pushing plastic out? We are. Let's go ahead and move this up. And I'm just gonna get this primed out here. I usually like to push about 50 millimeters through whenever I load filament in, so. All right, so once that's done moving up, it should start pushing filament out. There we go. So we are melting. We're only at 200 right now. Coax typically likes to run like 230. So I'm gonna go ahead and bump that up. And then what are we gonna print for our first test print? What do you guys want to see us print? I'm waiting. What are we printing? People, what are we printing? Are we still live? Cali Dragon? Oh no, is that those dragon things that people are printing, or is this something new? Post it in the Discord live streams channel. The Revo nozzle holder? That's actually a good idea. Let's see. Hey Tor, do you have the TH3D Revo nozzle holder ready? Tor? Tor. Tor. I don't think a Glock lower would fit on here. Also, YouTube would not be very happy with that. Let's not try to get my channel banned. That'd be great. You made one? Although, I don't think she's going to like this blue filament. All right, let's see. I'm just going to, let's see, let's find something new here. Oh, wait, we have a TH3D Cali Cube. Hang on. I don't think I've ever printed it on here. Tor gave me one. Or not Tor, Tyler made one. I'm trying to remember what it is. If I have it. I have my I have the TH3D coin here. Let's just do a TH3D maker coin. How's that? So, all right, we're going to have to tune the profile a little bit. So let me get here's our little maker coin in here, and I have my Ender 2 profile here. Armill said he sent the link in the lounge. Let's see what Armill sent. If not, we'll go ahead and, all right, let's see. Cali Dragon? Okay, this is pretty cute. This is totes adorbs. We're going to go ahead and do that. What? Why are you so angry? Is this what came in? Is that what this is? Oh, okay. Fine. Oh yeah, this is, so what, I think this is Flash Forge. So I do buy filament other than coax, because coax, if you guys are listening, I want fancy colors. And sadly, it seems the only places that make them are the Chinese filament companies, but I think Tor found this one, and it looks cool. So, and he said it prints pretty good. So this is, fair warning, I have not printed with this brand yet, but it does look cool. So, all right, we'll switch it out. How's that? We'll take the boring color out. And we'll put the Flash Forge in. So hopefully the Flash Forge prints well with my standard PLA settings. Now, those of you guys that have went from the stock hotend to the Revo, how much did you have to lower your retraction by? Because it does make sense. Most times when you go to all metal from a non-all metal system, you do want to lower your retraction. So, all right, let's go ahead and put this in and purge it out. And then we're going to get the Cali Dragon what's it called? Cali Dragon printed up. I thought y'all were messing with me when you said Cali Dragon, to be completely honest. I thought you were talking about those dragons that you see on the Tic Tacs. So if anybody wants this filament, I'll post an Amazon affiliate link here, because why not? I bought it with my money. It looks pretty cool. All right, so I'm going to go ahead and push out 100 millimeters. I always do 100 if I'm changing colors, so we're going to let this go. Tor, what are you DMing me? Oh, the Revo nozzle holder. Okay. All right. I got Cali Dragon, I think. MMU. No, I don't want MMU. Keychain. All right. Well, that's purging here. I'm going to go ahead and pull this into Simplify because it's still my slicer of choice. All right. So here's my Ender 2 Pro profile here. Ender 2 Pro profile, and I was using a retraction distance of 3 millimeters. I'm going to set this down to 2. How's that sound? And I'm going to go up to I'm going to do a quicker retract. I'm going to do like 75. And we don't want any support. This profile is pretty well dialed in. So let's go ahead and slice this and get a little preview here. Should we do more infill? No, I think we'll be okay. How many top and bottom layers do I have setting here? So 4, 4, and 4. 2 outer shells. That'll be good. All right. Bring up my machine control panel here. We can tell it it's on COM5. It should be 115,200 for the baud rate. And there we go. We got the machine connected. I'll do a G28 just to make sure everything's working. There we go. All right, we're going to go ahead and start this print. All right, prepare to print. There's my Ender 2 profile. And we're doing printing over USB. So there we go. We were already preheated, so. I will be making the move over to Super Slicer. That's my plan. It's just time. Now, try not to cry, BL Touch users, as you see how fast our probes run. This speed also could be yours as well. Although, look at here. I'm probably going to set this inset a little bit. It's probing a little too far back on the bed, but I think we'll be okay. I think I set the mesh. What did I set the mesh inset to? I think it was 10. I'll probably have to go like 20. 35 is our firmware default. All right. Now, I do not have a Z offset set. I might have it where it's like almost not needing one, but we'll find out once it gets to the center of the bed here. I need to take my hat off for this. Oh, that's dead nuts. Okay. We don't even need to have an offset. So if you mount your sensor at the right height, sometimes you can have a 0 offset. I'm just going to leave it. There we go. I don't... If I put this printer on... Hang on. Let me set this printer on top of one of my boxes so I can actually get a better view, because this printer is so tiny. So you guys can actually see it doing the needful. All right. So I can actually get an angle at the bed here. Let me set the manual focus. And we're going to see how this comes out. Looks pretty good so far. Yeah, I'll post a link to the filament. Let me get that. All right, yeah, purchase. I bought this July 18th. It is a cool looking filament. We are looking at expanding our filament line outside of just U.S. manufacturers solely because I can't find any of these cool filaments from U.S. manufacturers. So I've asked them, and basically they said they have no interest. So all right, there we go. So that's what we're printing with right now. I see a dead pixel on my camera. Do you guys see that? It's like a stuck pixel on the left there. All right, she's printing. While we're doing that, I'm going to go ahead and build a new firmware that has a better mesh setting, just because it was a little too far in, or a little too far to the by the edge on the rear. Now, when you have when you have your sensors, you want to make sure you're probing a little bit in on the bed, not at the very edge, because you can get erroneous readings. So I set the edge setting on this to 10. If I do 20, that'll give me right where I want it. So it's printing nice. All right. I'm going to go ahead and save. I have a folder on my computer called Printer Firmware. And I'm going to put that in a file called Krista E2 Pro V2, so I have that saved. This is a quick print. Thanks for suggesting that. All right. This is printing really smooth. What is your guys, since we're doing a test print, this actually might be one of my new favorite test prints because it's small and it's quick. What are your guys' go-to test prints other than Benchies? What is everybody's preferred test print? Yeah, Cali Drag Infinity Cubes. What are Infinity Cubes? I have not heard of those, but they sound interesting. I don't know about you guys, but the print's looking really good there. Let me see if I can get more light in here. I got another light right off to the side here. Let me see if I can get some more light in here. Ugh. I am printing over USB. Did you see my thing pause for a second there? I'm printing off of the same computer that I'm streaming with, so hopefully it doesn't anger the print gods. Oh, Disco Vision. Yeah, Anders Engers Jensen. This right now that's playing is From Zero to Z, which is my friend Max's husband Josh's band. And they got all sorts of, like, you know, digital type stuff. And some, like, alternative rock. I think Remo needs to go outside. Do you need to go outside? Can you speak? Tell me what you want. What do you want? Show me. Go show me what you want. You want to go outside? Yeah? All right. Let's let the pup outside. I don't need an accident in the house. Although he's a good boy, he'd hold it. Either that or he's trolling me and he just wants to go out. Who knows? Let's see if I can get that light in here. How's that? Is that better? You guys like my camera setups? Can really get in there and show you the detail. It is printing nice. Tripod, your dogs want to go outside? Hey, Bear, Bear, do you want to go outside? Or does Bear want a treat? Bear is Tripod's dog. Thing 4997903, let's see. Oh, the infinity cubes, the fidget cubes. Okay, if somebody has ADHD, I love those things. I literally... Hang on. Here's one I printed on my Under 6 in PETG. Okay. And then Krista also bought me one of these little guys. Like this little doohickey. It's just got like buttons and little tactile things. It's great. I really should keep this in my pocket because it does help me focus on things. And then here's the one she bought me too. This is like a injection molded one. I love these. Look how nice that's printing. I think the last upgrade we'll do on this, I mean, basically this printer is going to have over twice as amount of upgrades in it as the damn printer costs. But you know what? I don't know about you guys. I'm weird. I like taking like these little cheap printers and just putting all sorts of awesome upgrades into them and making them print amazingly. Like I don't know why, but yeah, it's a thing I like doing. It's a beautiful color. Like I wish there were more options for colors like this from US-based companies, but basically the thing is like they only have most of them only have so many extrusion lines and they're already, you know, at their max capacity, so it doesn't make sense for them to make all these like you know, specialty ones. But yeah, it's a cool looking filament for sure. And I did post, I think I posted a link in the chat here. I lost my window that's got, there we go. So this is the filament we're printing with. It's the Flash Forge burnt titanium. So there you go. If you want to pick one up. Oh, wrong one. That is my path to my firmware folder. That's not going to help you guys. I'm grabbing it again. Sorry. That's the wrong one. That's useless to you guys. Here we go. There you go. So right now, what is it? Like it's like $27.99. That's not terrible. It is one of the more expensive ones. So, but you know, it's on. That's like what within a couple bucks of most of the U.S. filaments, but it's got good ratings on here, and they also have a lot of cool colors. So. Yeah, I mean, I think part of the draw, I mean, at least for me anyways, before TH3D was even a thing, like, the draw of, like, buying, you know, these cheap printers and upgrading them to exactly what I want is, you know, something I really enjoy doing. You know, it's, you know, for example, like, I actually just purchased a used riding mower, and it had a bunch of stuff wrong with it, but I actually found it enjoyable, to repair it, and luckily the guy actually gave me money back. He thought I was going to want to return it, but I was like, nah, just give me money back. I can fix the issues with the motor. But like, it gives me a better understanding of how things work. And, you know, I love figuring out how things work. So, but that's just me. What about the peanut gallery? What does the peanut gallery think about any of this? Henkel Energy. Hey, the mower has a 26 horsepower polar motor, and it's got a cup holder, okay? And I put a cigarette lighter on there so I can charge my phone while I mow. I just gotta put new blades on it because they're very dull. I'm gonna keep the old set to sharpen them, but I bought a whole new set for like 45 bucks, and they're made in America. All right. Yeah, this is going pretty good. I think I sliced this at like 60 millimeters a second. It says it'll take 26 minutes. So in simplified 3D estimates, or just in general slicer estimates, so what's that, like 35, 40? I'm going to speed this up a little bit. I'm going to set my feed rate to like 125. 130, close enough. There we go. I just adjusted it from the slicer. So she's moving. And this printer's really quiet. It's got our EasyBoard V2 in it. We just put the Revo on here. Got our Tough Tube for the PTFE tube, our silent 40mm fan for the hot end cooling, and then the Easy ABL Micro. I mean, I think just between the Easy ABL kit and the board, that's like $170 in upgrades, which is as much as the printer cost. And then we just put another, you know, $100 hot end set because it's the full set. So, but hey, it prints beautifully. This is printing really good. I literally just took my Ender 2 Pro profile I had for the stock hot end, dropped the retraction down a little bit, and you can see we're doing pretty good. What slicers is everybody using these days? You know, the only reason I'm still on S3D is moving over from one slicer to another, given the amount of printers I have, and just like the workflow, it's a big task. So, you know, at some point I'd like to get my feet wet and, you know, cut my teeth on Super Slicer. I think that's going to be the one to go with. Idea Maker was a little clunky. I kind of like Super Slicer because, you know, it's got, you know, basically all the same features as Prusa Slicer. It's open source. You know, if I'm going to spend time learning a new one, might as well get something that's open source. Maybe we'll have a TH3D Super Slicer, the Easy Slicer. We'll fork it and make our own, the Easy Slicer. As if I need one more project to keep track of. This is printing beautifully, though. E3D did a good job on this hot end. And it's nice that they use the same thermistor type as the stock one. So this actually still has the stock cooling on it, so because it's been working fine. So Skydown says he's using Kira, Prusa Slicer, and Bamboo Slicer. Mac CJ says Super Slicer and Kira. I use Kira. I've loaded Prusa Slicer, haven't used it yet. Yeah, I'd prefer to just use Super Slicer just because I don't want to be using Prusa brand and stuff. Well, I do have one of their printers, but I'd rather have something that's like brand agnostic, so to speak. You know what I mean? Kira. I do not like the workflow in Kira. That's the main reason I don't like using Kira, is like just the workflow is really weird.
You found me again. Welcome back.
This is coming out really nice. Like I'm actually just watching it on there. This filament looks so much better in person though. Like this looks so cool. Like this is printing beautifully. I didn't check the temperature. They're saying 190 to 220 for the print temp. We're at 220. I like to run my PLAs a little bit hot. And like, here's the thing. I also bumped the feed rate up to 130. So we're printing a little bit faster, but this is coming out beautifully. I don't even know if I should put the new Tough Extruder on here. What do you guys think? Should we hook Chris up with the new Tough Extruder V2? I won't do it tonight, but because I gotta go after we're done with this, I gotta go paint my living room. YouTube didn't remind you. Redline, go in our video description. There's a link to sign up for YouTube notifications, and we'll email you 30 minutes before any live streams. So, and it actually works. We actually have an email notification system that works, unlike YouTube. Tor says with this filament, because he's printed with this before, that's how we have it, because he posted a picture of a print he did in one of our Teams chats, and Chris is like, oh my god, that's pretty, I want it. And boom, we have it now. So hey, we ended up using it for a stream.
I'm sure you'll find using your new MCA disk division system to be rewarding.
Who's still using SkinForge? Fess up. Is that a FlashForge like rebrand of an open source slicer? I've never heard of that. Oh no. No. Your printer's almost done, okay? Don't hurt me. Please don't hurt me. Go ahead and let the dog in. He loves Printing Panda. Printing Panda wants its printer back. We're still going. It still looks great. Now, pandas are kind of like other animals where if you don't move, they can't see you. So I'm going to try my best to be calm so I don't get mauled. This is a cool little test print. Okay, it's not looking at me. So I can move now. Okay. It does not, I do not have its attention. I'm safe for now. I can grab my drink. Luckily, I have surveillance on it. I'm watching it in my camera preview. No sudden movements. I think it might be distracted by the cube back there. All right, we're about it says 64% for the print right now. If you guys have never printed with S3D over USB, it actually gives you a preview here. So this is where we're at. So we got a little bit to go. So this is just streaming the data over USB. Now, the thing I don't like printing over USB is if you're doing a long print, your computer goes to sleep, you're gonna lose the print. So, but for just testing like this, not a big deal. But you can see where we're at with the print. So this is our live preview tracking here. I'm gonna have it update every second. So these are the commands that it just sent to the printer. The head is coming up. Does anybody have any bear mace? Remo, help! Attack! I'm gonna move the camera a little bit. There we go. Remo's protecting. You know, if she actually stood up and I was like, help, help, Remo would probably try to bite her. Maybe Panda can win over Remo with a dingo stick. How about I drop one into the panda suit and then Remo can try to get it out? Mm-hmm. There we go. Now the dog is distracted. Alright, hang on. Let me look at the chat and see where everybody's at. Where's my chat bot? Where's my chat bot? We're at 75%. It says we got 6 minutes left, and we're going to take a look at it. Okay. Printing Panda, you don't like my print? Slaps printer off the table in rage. No, let's not slap the printer off the table in rage. I mean, Panda would be killing its own printer, so... Am I ever going to build a Vora and do that not interest you? They don't interest me. They are good printers, but I don't want to promote that particular machine because the community, in my opinion, is very toxic, and I'm not going to promote a toxic community. That's just my opinion on it. But the printers themselves are great. It's just the user base is something. So Doc or DJ Sir said, I bought the Sunloop S8 knowing it'd be junk on the box, but knew it'd be better with upgrades. I put in a W21, I don't know what you mean by W21 bit board with 2209 drivers, Clipper and ABL, prints like a dream. So the S8 is actually not a bad machine. Even the stock board, if you change the firmware out, is pretty good. I actually have the S8 Pro here still in the box. That's going to be one of the upcoming streams. We've been trying to do more streams every week just because we have a lot of stuff we can do streams on, and I know you guys like watching this. But yeah, the S8 was good. I have the S8 Pro sitting here, which I think is basically it's like the S8 with some extras added on and silent drivers, if memory serves correctly. I actually bought the S8 Pro to test to make sure our firmware works on it, because someone said they were having issues, but I don't know if it was user created or if Sunloop actually changed something between the two printers in terms of board setup. We're getting close. What does it say we're at? We're at 83% now. And like I said, for most of this print, I actually pushed it up to 130% feed rate. So this little printer can actually print pretty quick, even with like a standard non-geared extruder that's on here. So basically, the extruder that's pushing the film right now is our upgraded aluminum one. So if you guys are looking for just a cheap drop-in upgrade for your Corelli printers that come with the plastic ones that like to break, we have those in our shop. And they're a really quick and easy upgrade. And you don't need to do any firmware updates to change it. So if you don't want to update your firmware, you can just switch it out. Whereas, you know, other extruders like our Tough Extruder V2 or any of the BMG ones or other aftermarket ones, especially geared, you're probably going to have to change your E-steps, which usually requires a firmware update. S3D is great, but it costs money and no updates. So I've been using S3D since 2017, and I'm still using the same license. So I've got my $150 worth, and I think we bought 3 additional licenses. So we have 4 total licenses, and you get 2 installations per license. So I've got 8 total installations. So I've got my computer, my laptop, Krista's laptop, and her computer, and then like our print farm machines. So I've got my money out of it. I have no problem paying for software. If it's worth it. And like, I don't care that S3D doesn't have many updates because I put a file in and I get thing out. So that's what I want my slicer to do. But I would like to play with something newer and see what newer features are. But you know, the thing is, there's nothing stopping me from using S3 and I already have it. Would I buy it now these days? You know, if I wasn't already invested in it, probably not. But let's see. So it's going between the ears, and you can tell I have the retraction is adequate because we're not getting any stringing between the two. If we were retracting too little, you'd start seeing like little wispies coming off, and there's maybe a little one. I can't tell in the video preview. But we're gonna see. It's doing the little antlers or antenna or whatever it is. The ears. Are we going to sell the E3D Revo? We're looking at selling them, but again, we want to test them, make sure. But so far, I'm impressed with like the ease of use, the quality. You know, we do want to get some other hot ends in that are, you know, higher end ones. So we do have our tough hot end, which is based on the V6 design, which is what E3D came out with before the Revo, and that's still a great design. You know, but it's just an older design. But, you know, at the end of the day, your hot end's got to push, you know, plastic out of a little nozzle. Stop shaking the table, please. But yeah, so you can see there the stock Ender 2 Pro cooling is not really keeping up there. So this is the stock cooling fan and the stock duct. So I haven't done any upgrades on the cooling fan on here. And you can tell that by seeing now the little antler or antennas, whatever they are like kind of curling up there. That's an indication that there's not enough cooling. And I'm not surprised. Like I said, the stock cooling on this printer is just okay. It's not great. It's not terrible. You know, but it's not as good as doing like an aftermarket 5015 fan. So, but so far this is coming out really nice. Oh, we got a little wispy there. All right. So let's go ahead and take a look. Remo, I'm going to roll over your tail. Move. Remo. Go. All right. Well, let's take a look at our little dragon friend here. Let me zoom out a little bit. Let's get this in focus. There we go. So this I'm not really worried about. I could probably up my retraction a tiny bit, but not bad. See, it just comes off if you touch it. And then we're going to go ahead and flex this off with the Easy Flex. There we go. I heard it pop. And look at that. That came out fantastic. Let's get that in focus there. Come on. There we go. This is definitely a cool looking filament. Look how nice that came out. So you can see there, this is like overheating here. Now I could change where the Z seam is. That's what you're seeing here. Is it's like stitching and maybe make it a little bit cleaner, but all in all, it's really good. Also, better cooling would help. But again, this printer's cooling is completely stock. And this is pretty small. Like, this is a small little test print. Like, I don't know. Here's an SD card adapter for comparison to give you an idea of the size. So this is a full-size SD card size. So it's adorable. Yeah, print quality came out great. I'm very happy with the quality of this hotend. So, you know, the stock hotend gave me good print quality too, but this I think is a little bit cleaner. You know? I like it. What do you guys think? It's a little Cali Dragon. I'm definitely going to be printing more of these. Maybe I'll print a big one on Bertha. There we go. I didn't know that's what you were saying. So, anyways, all right. I'm very happy with this. So, in terms of, like, the upgradability on this hotend, I really like the quick nozzle swaps. So, like, if that's something that appealed to you, like, I think that would be my #1 selling point on this. So, in terms of print quality, like, it's a little bit cleaner than what you're going to get out of a stock hotend. Is it night and day difference? I'm going to say no. So I think if like I had the same exact print side by side, printed with the stock Pirelli hotend, with like, you know, our tough tube in there, or even like the bimetal heat break versus this, you probably wouldn't be able to tell a difference. But where I can really see the value in this hotend is being able to just literally unscrew the nozzles, drop it out, put it in, and never have to worry about the filament leaking, because the nozzle and the heat break is one assembly. So the downside of that is the nozzle and the heat break is one assembly, so the nozzles are a little bit more expensive. I'm actually look up here and see what those are in US. I think Matter Hackers carries them, so I can get an idea. So, wow, these are actually way more expensive than I was thinking. So, just for example here, this is nice, but, you know, for me, in terms of like somebody who's used to using this is a little steep per nozzle. Again, this costs more to machine. I do like the system, though. This is really expensive per nozzle. What is a 3-pack? 3-pack is $68. So, like, just for comparison, to give you an idea, and we'll use Matter Hackers for comparison because they're in US dollars. So you're paying $26 nozzle, and these are the standard nozzles. So what does the REVO CR go for? So here's the REVO CR 24 volt. So you're paying almost $100 for this hotend. Now, machining quality and the fit and finish, I do think it is punching in the correct price point. So what are we looking? So the kit we're looking at here that they sent us, this is the $150 one that comes with all the nozzles. I do think that's a good value if you're going to get into the Revo ecosystem, because you're getting 4 nozzles with the hotend. So I do think it's a good buy, especially if you're somebody who swaps your nozzles out a lot. And the print quality is good. E3D makes good products. You know, I really don't have any complaints about their stuff. So, but yeah, they are, like, this is the downside. Like, for example, you know, if we look at, you know, apples to apples comparison in terms of hotends. So, like, you know, let's look at just, like, these are our high-end nozzles. So, you know, for, like, your Creality MK8s, you're talking about for the copper plated nozzle, you're talking $15 a nozzle. You know, for the V6 style, you're at the same. For just standard brass nozzles, you know, for like your Creality hotends, you're talking like $2. So it is more expensive, but I think that quick change is really, really good for people who want something like that. You know, for comparison, here's our hot end here. This is based on the V6 design. This is also a high temp one. This actually goes up to 320C. This one is $35 and we include a bunch of nozzles. So the trade-off is you're getting easier, you're getting ease of use. And I really like how quickly it heats up. So that's another plus. But if you're somebody that is switching nozzles all the time, I can definitely see the appeal of this hot end. In terms of print quality, build quality, thumbs up all the way around on there. But what do you guys think? Does anybody have the Revo? I know Tor has the, I think he's got the Voron edition of the Revo or whatever it's called. It's not the V6 style one, like the groove mount style. So, yeah, I can definitely see if you're somebody that swaps nozzles all the time, I would purchase something like this and use it regularly. So that's one of the reasons I put it on her printer, is so she can change nozzles out fairly easily without having to go through a complicated nozzle change process. So, you know, it does cool down fairly quick. We're already back at room temperature, so like let's see how easy this is to change out the nozzle if I want to change it out. Let's zoom out here. There we go. So if I want to change the nozzle out, then we are at 34C, so it is cool enough for me to touch without burning my hands. Oh wait, I'm gonna have to take the filament out. Actually, I can do that. No, let's heat it up. It's not like it takes long to heat. You can see here, there's our target temp, there's our current temp. I just want to get it up past 100 something so we can get the filament out. Might have to get it a little bit hotter. Waiting to see it come out the nozzle a little bit. There we go. And I'm going to pull it back. All right, so now we're in the PTFE tube. Let's go ahead and let this cool. And let's do the 0.8. Let's see. Or actually, wasn't there a 0.5 in this kit? Or am I thinking of something else? I'm looking here. 0.8, 0.25. 0.6 is like my happy medium for nozzle sizes. So here, 0.6 is the blue one. All right, we're letting that cool down. The shmoo off there. We're at 150. Once that gets under 100, I'll go ahead and change it out. But look how cute. He came out so nice. Cool down. 0.6. Yeah, so 0.6, I think if you're looking for something that's a little bit bigger than stock, but you still don't want to lose detail on smaller prints, the 0.6 is my personal preference. I have multiple machines in my office here with 0.6. All of our print farm is 0.4s. We've been talking about going to 0.6 just to, you know, reduce print time. You know, and 0.6 will actually give you a little bit stronger parts too versus a 0.4. So there's a lot of pluses with going with a larger nozzle. So I'm just waiting for this to get down to temp. You see right here, it says 100. I want to get down to like 60 or 70 before I touch it. Still going. It does heat up really quick. David Stockdale, I also thought I heard him say you can't reuse the nozzle if you swap it out to something else. Remo? Hang on, Remo is about to unplug a bunch of stuff. Go. Go. Get out from under the desk. I don't know why he's laying under there. Yeah, you can definitely reuse the nozzles. All right. So let's see. We're at like 80. It's still hot. Not like burn myself out, but it's uncomfortable. All right. Let's see. See how easy this is. What the hell? Why did the printer go to max temp? All right. Well, let's do it with the power off. I'm wondering if it didn't like, if like one of the wires, what's it called? Like, cause it to read high. All right. Putting that up in there. I was wondering why it was moving. Unless maybe there's like something touching like the temp sensor. All right, let's turn it back on and see. I'm wondering if they have a thing inside there that like makes it contact if like ground out the sensor or something. Let's see. No, we're good. So yeah, that's literally as easy. That's how you swap the nozzle out. That's really nice. So I like that a lot, actually. And you can see here, there's our heat break nozzle combination here. So yeah, is it expensive? Yes, it is. But like, this is actually really, really nice. I kind of want to get these in. What do you guys think? Should we add this to our lineup in the shop? I like it. All right, let's just take one more look at the Dragon. We're going to wrap this up. Let's see here. 'Cause this came out really nice. Look at that. That is a gorgeous filament. All right. Well, with that all being said, I appreciate you guys stopping by. I appreciate E3D for sending this out for us to check out. I really, really like this swap system. My only complaint is I wish the nozzles were a little bit cheaper, but like I said, it's a nozzle and a heat break all in one. So that's going to bring the cost up. But if you're somebody that hates changing nozzles, having to hot tighten them, and, you know, do really complicated nozzle changes, I think this is worth the cost, you know, me personally. So as somebody that knows how to do regular nozzle changes, that was really nice to be able to just swap it out. So, anyways, if you guys want to check out more live streams, you can go ahead and click our YouTube channel. We have all the VODs and everything. We also cross-post our content to Odyssey and Rumble as well, so this replay will be up on those platforms also. Every Wednesday at 4 p.m. Central Time, we do a live stream here. You can ask me questions about your 3D printer and get help with your machine. And then typically we've been doing the random live streams like this that are either like printer reviews or upgrade streams, or hangouts towards the end of the week on, you know, Fridays or Saturdays. So hope you guys enjoyed. I had a good time hanging out with y'all and building this. I'm really, really impressed with the quality of this Revo. And again, I appreciate that they sent it out for us to check out. And I'm literally going to send them an email asking them about how we get, you know, pricing on reselling these, because I definitely think that this is something that we should carry in our shop because it's a nice product. If you want to be able to swap your nozzles out quickly, they did a really good job with it, you know, and it checks all the boxes, you know. Mainly my biggest thing is the fact that it comes with the silicone cover for the heater block and everything, and the nozzle. I really like that. The color coding system is nice once you figure out what it is. Yeah, so anyways, I will talk to you guys later, and as always, happy printing. I will see you guys on the next stream.